Today we're looking at multiplication properties of exponents. You may want to pause the video and just jot all these first couple examples down. Okay, so to give you an idea of what we're going to be doing in class, we have x squared times x to the fifth. So how I want you to think about this is x squared means x times x, and we're multiplying that by x to the fifth, which means x times x times x times x times x. So when you write it in expanded form like that, you have a total of 1, 2, 3, 4, 5, 6, 7 x's, which means that equals x to the seventh, because you're multiplying all of these x's together. Okay, likewise, if you use a different variable, if they're the same base, which these both are, they're both y's, you've got y to the third times y to the sixth. That means y times y times y multiplied by y times y times y times y times y times y, which when you count up, you have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9 y's being multiplied by each other. So in other words, y to the ninth. Okay, one more example like this. Z to the fourth means z times z times z times z times z to the fifth, z times z times z times z times z, which when you count them up, you've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, z to the ninth. Hopefully by now you have recognized the pattern that whenever you multiply two like bases, that just means these two bottom either numbers or variables are the same. When you're multiplying two like bases, you add the exponents. Hopefully you notice that. 2 times 5 equals 7, 3 plus 6 equals 9, 4 plus 5 equals 9. So the rule, this is our rule, if you multiply two like bases, you add the exponents. So that'd be like a plus b. So let's look at a couple of examples using that knowledge. So here, the only difference is instead of just having two like bases, I also have numbers in front. So before I worry about the x's, I've got to take care of the 2 times 3. You handle that like normal. 2 times 3 is 6. Okay, and then you've got x to the 6th times x to the 7th. So using our rule, you're going to add 6 plus 7. So my final answer is going to be 6x to the 13th. Okay, here, same thing, okay, except for I've got 3 terms now. I've got this term times this term times this term. I'm still going to handle the multiplication of the numbers like regular. 3 times 2 is 6, and 6 times 4 is 24. And then remember, the bases have to be alike. So first, I'm going to tackle my x's. So I've got x, x to the third, and x to the fourth. Well, here's the deal. You have to remember that x is the same as x to the first. So I've got x to the first, x to the third, x to the fourth. So that's like 1 plus 3, which is 4, plus another 4 is 8. So x to the 8th. And then looking at my y's, I've got y to the 5th, y squared, and y squared. So that's like 5 plus 2 plus 2. So 5 plus 2 is 7, 8, 9. So y to the 9th. Okay, looking at another property, if I raise a power to a power. So if I've got x to the third to the fourth power, that fourth power there means I've got 4 x to the thirds being multiplied by each other. So if I expand it like that, like I said, 4x to the thirds, and then if I go one step further, that's really like x times 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 x. So again, same situation. Add up all these x's, you've got 3, 6, 9, 12, so x to the 12th. Okay. Similarly here, if I've got x squared cubed, that means I've got 3 of these x squareds. All right, so that means x times x times x times x times x times x And when I total it up, I've got 6 x's here. So hopefully the pattern you have noticed here is that in order to achieve this number, you're actually multiplying these two numbers. So 3 times 4 equals 12, 2 times 3 equals 6. So here my rule, when I raise a power to a power, is that I would multiply those two numbers. So trying a couple of examples, kind of jumping straight to something a little bit more difficult, that means x to the 8th y squared 3 times. So using our rule of multiplication, that means you're going to need to multiply those numbers there and those numbers there. So that would be x to the 24th, y to the 6th. Okay, using our newfound rule. What I want you to be careful of is something like this next example, because sometimes you have a number in front. Here we didn't, here we do. When you have a number in front, you don't multiply those two numbers. That's incorrect. What you're actually going to do is you are going to raise 2 to the 5th power. So that means 2 times 2 times 2 times 2 times 2. Okay, so you're going to do that, and then you're going to use your rule that you multiply these numbers here. So I've got 2 to the 5th power, m to the 15th when I multiply, n to the 35th. So once I do my math of 2 times 2 times 2 5 times, that's 32, m to the 15th, n to the 35th. Okay? Last step where I combine everything. So combining everything that we just learned, I want you to remember that always in math, PEMDAS comes into play. So combining what we just learned, we cannot multiply these two guys first because we've got exponents outside. We've got to take care of the exponents before we take care of the multiply. So the exponents need to distribute in first. Okay, so this means 5 squared. And then when I multiply, I get a to the 12th. And remember that there's an implied 1 here, and 1 times 2 is 2. So b squared times 2 to the 3rd power. When I multiply here, a to the 12th, b to the 6th. So my final step now is to multiply. So I've got to do 5 squared is really 25, and 2 cubed is really 8. So I've got 25 times 8. So 25 times 8 is the same as 200. And then when I am multiplying these two, remember that what I do to the exponents is that I add. So that's a to the 24th, and then b to the 8th. Don't forget to complete your whisk.